All right, we're going to pick up exactly where we left off. So we had addressed what a one solution is going to look like, ordered triple. So now we're going to look at what a no solution, aka an inconsistent system, looks like, and then more specifically what many solutions is going to look like. So let's go to example number 3. So we want to decide which variable to eliminate. I'm going to go ahead and I'm actually going to eliminate the y's this time. So we'll call this 1, 2, 3. So I'm going to use the first equation. So 3x minus 2y plus 4z is equal to 1. So I want that to become a 2. So I'm going to go ahead and multiply everything by 2. And I'm going to do this first. So here is my second equation. So 2x plus 2y minus 4z is equal to 6. All right, so what's going to happen? 3x plus 2x gives me 5x, and those will cancel out, and this will give you 7. Interesting. No solution is supposed to be, variables are supposed to cancel out. You're not supposed to get an answer. This looks like we have an answer. So let's see if we can actually solve for a different variable, right? Let's try to eliminate something else and see what happens. So we didn't use the third equation yet. So let's for sure use the third equation. So 2x minus 3y plus 6z is equal to 8. And this time, I'm going to try to eliminate the z's. Let's see what happens. So I'm going to use the second equation. So since I've already used the red, I'm just going to rewrite this equation and look like I manipulate it. So x plus y minus 2z is equal to 3. So this time, I'm going to multiply everything by 3. So multiply it by 3. So what am I going to get? This equation stays exactly the same, which is great. This is going to become 3x, and this will become plus 3y minus 6z is equal to 9. Add these equations together, I'm going to get 5x, which is what I got over here. My y's cancel out, my z's cancel out, but this time I'm left with 9 plus 8, which gives me 17. So this time I get x is equal to 17 over 5. So this is one example of what an inconsistent system looks like. It's being inconsistent. Sometimes x is equal to 7 over 5. Sometimes x is equal to 17 over 5. If we cannot always get the same answer, it makes it inconsistent. So inconsistent, which means, aka, there is no solution. Okay, the other way we can actually see this kind of an inconsistent no solution is when this happens. So when all your variables cancel out and left with a false statement. So what do I mean by that? I mean like 0 is equal to 1. That's obviously a false statement. That means that no matter what variables I plug in, I will always get the right side and the left side not equal to each other, aka it's a no solution. So there's two ways that we can actually get a no solution. We're used to this way, okay, when all the variables cancel out. We're not used to potentially getting two x's to be the same. So this is one example of an inconsistent solution. So now let's see what a many solution is going to look like. So here's our example. I also really like this example because you actually don't need 3 equations with all 3 variables. All right. So again, I'm going to call this 1, I'll call this 2, and I'll call this 3. Okay. So there's a couple ways that we can kind of go about and do this. Okay. So, so what I see right away without manipulating a lot of things is that if I add the first and the third equation together, I'm going to get rid of those x's. So that's exactly what I'm going to do. So, so I'm going to get, so x plus y minus 3z is equal to -1. Negative x plus 2y is equal to a positive 1. Boom, add them up. So 3y minus 3z, and then that is equal to 0. Brand new equation, number 4. What's great about number 4 is that you can always make your equation smaller. So if I wanted to divide everything by 3, I could do that, right? So I could get y minus z is equal to 0. And the reason why I do that is I want to bring your attention back up to the second equation. So sometimes you don't need to add the second with the third equation because notice that the second equation won't be able to eliminate an x. So I'll still have an x. So what I actually want to do is I want to use my second equation. So y minus z is equal to 0. But then I'm going to use my fourth equation, which again, I'm going to use the simplified version. Y minus z is equal to 0. Notice that they're the same equation. So if I multiply it by -1, that would turn positive. This would turn negative. This would turn positive. That stays the same. Which means, notice what happens. Those cancel out. Those cancel out. 0 is equal to 0. Right? This is a true definition of many solutions. So we have many solutions. Okay? But at this point, what happens if I asked you, give me an example of a many solution? What is an example that's going to work with all three of these equations? So I don't want to play the guess and check game. So I want to come up with expressions. So this is what I meant when I said over here, find expressions to help figure out all the ordered triples. Okay? So the first thing that I'm going to do is I'm going to write a let statement. And I'm going to let any of the variables equal another letter. So I'm going to say, because me being consistent, I always like to use z. So I'm going to say let z equal a. And a is any number. It could be any, you know what? Instead of any number, I'm going to say any real number, because again, we will see, so any real number. Okay, so that means everywhere I see a z, I'm now going to replace it with an a. So, and now I'm going to solve for all my variables in terms of a. Okay, so solve for x and y in terms of a. All right, so the first easy one would be our second equation, or I could have used my fourth equation, either one. So, so second equation right here, and so y minus, now instead of the a, or sorry, instead of the z, I'm going to write an a. So I'll write it with a different color so we can kind of see that. And then it's equal to 0. So I'm going to solve for y. So y, add a to both sides, is equal to a. So now I have two of my variables. What do I have to do? I have to solve for x. So I can either use the first equation because it has an x, or I can use the second equation because it also has an x. I like my x's to be positive, so I'm going to solve the first equation. So again, this will become x plus, now instead of y, I know my y is an a. So an a, and back to black, minus 3. And then what is z? Z is also a, is equal to, sorry for switching colors, kind of trying to color coordinate it, equal to -1. So now let's combine like terms. So xa minus 3a, so that'll be minus 2a, and then equal to -1. Add it to the other side, so -1 plus 2a. So again, now if I plug in a value for a, I will get both the z, the y, and the x. So when I write my solution, so instead of saying many solutions, I'm going to write as an order triple. So -1 plus 2a, and then my y is an A, and my Z is an A. So now I can say, what is a solution? So here's so if we want a solution, I could say, let A equal 2. So then 2 times 2 is 4, 4 minus 1 is 3. So 3 comma 2 comma 2. Or I can say A is equal to 0. So this will be negative 1, 0, 0. I can say A is equal to 1. So 2 times 1 is 1, 1 minus 1 is 1, so 1, 1, 1. So notice that I have 3 solutions, and again, I can check them all into here. All right, so this one is a little bit more complicated than the inconsistent, so I do want to show you one more example of this. Okay, so again, I'm going to call it 1, 2, and 3, and I'm going to go ahead, looks like it's easier to manipulate the x's to get rid of them. So for sure, I'm going to use the second equation. So 2x plus 3y plus z is equal to 5. And then I will use the first equation, and I'm just going to go ahead and multiply it by negative 2 right away. So negative 2x minus 4y plus what? 14z is equal to 8. This will cancel off. I'm going to left with negative y and plus 15z, and that gives me what? 13. Brand new equation. Let's call this a 4. I have not used my third equation yet, so I got to write that one more time. So 3x plus 7y minus 36z is equal to negative 25. Again, I'm going to use the top equation because it looks like it's easier to manipulate it. I'm just going to say what happens if I multiply it by negative 3 instead. Right? So what do I got? What do we got? So, change my color. So this would become negative 3x minus 6y and then plus 21z, and then that would be positive 12. All right, add them up just like I wanted. I wanted these to cancel out. So I'm going to get a positive y this time, and this is going to actually be a negative 15z, and this will give me a negative 13, brand new equation. Call that number 5, and notice that if I write the fourth equation right underneath it, these two are going to cancel each other out, leaving you with 0 is equal to 0. So this is where we come back, right? So this time I won't color coordinate it. I'm just going to write it in green. So I'm going to say, again, let z equal a. Again, it doesn't really quite matter. Do use one of the variables that we still kind of have left. So that kind of makes it easier. So I'm going to say let z equal a. So then I'm going to plug it into the fifth equation. So y minus 15a is equal to negative 13. So y is equal to negative 13 plus 15a. That was simple enough, right? So now what I need to do is I need to solve for x. So I'm actually going to use the first equation because my x is by itself. So x plus my y, which is now negative 13 plus 15a minus 7a is equal to negative 4. So x, and this will be minus, 26. So minus 26, and then plus 30a minus 7a equal to negative 4. So combine those terms, so 26, and then plus 23a, negative 4. Add the 26 over and subtract the 23 over to the other side. So negative 23 plus, it should be 22, I believe. And that is your x and your y and your z. So again, we want to write them as ordered triple. So negative 23a plus 22. It doesn't really matter which one you write first. Your book will normally put your variable first, so I'll put my variable first. So 15a minus 13, and then your z is equal to a. You will get different expressions depending on this. So if I didn't let z equal to a first, and I said let x equal to a first, then these would be completely different, right? So again, it's up to you to decide which letter you want to use to represent your first variable. I just like to choose z to begin with.